Jai Hind everyone, my name is B.N. Pandey and I am Assistant Professor in CSC Department in Ajay Kumar Garg Engineering College, and today I am going to continue this third lecture of compiler design, in which I am going to discuss the three address codes and associated semantic action. Basically, if you are talking about three address code, it is basically is a kind of intermediate code which is intermediate in between source code to object code. So you can say that you have just applying some process to convert the source code into intermediate code, which is easily you can take as input for code generation. Maybe at the level of registers, your efforts would be less because you are converting this code into three address code. So according to the name of three address, you will see that the three address is basically, you can see here there are three addresses involved. And the kind of expression is basically x equals to y operator z. There are two operands for performing operation. There will be one binary operator is there, and one particular operand is there where you have to store the result after calculating this particular expression. So this is called three address code. Why it is called three address code? Because maximum three addresses are involved. So if we're talking about x equals to minus y, x equals to minus y. So this is also a kind of three address code. It is basically, you can see that it is basically unary operation. So this is the three address code. So you will see that x, y, z is basically names, constants or temporaries. So what is the benefit of this three address code? Whenever you are going to perform any expression, perform any operation on the given expression, like this expression is given, a equals to b star minus c plus b star minus c. So if you are directly inputting this particular sequence into the computer, then you know that the registers will be available for performing this operation where the input is in the kind of this instructional format, and that instruction must have only one operator, because at a time one operator is operable. So for that purpose, what we are doing, that we have to convert the whole expression into three address code, so that whenever we are inputting these particular values for calculation into registers, at that moment there is no need to finding out the operator priorities and other things. So that is very important part, because it is intermediate kind of thing which is input to the code generation phase. So if you are talking about this expression, you have seen what we are doing. Firstly, we have to find out the priority of these operations. You will see that minus is the higher priority. So firstly, you have to taking this particular operation into, means all the particular expression which you will see that is converted into three address code is basically in the form of three address code, like t1 equals to minus c. Okay, you will see here there is no more than one operator in one expression. If you are converting any particular code into this form, then it will be easy to calculate this expression by using registers at the hardware level. So that is the purpose of converting this three address code, converting this larger expression into three address code. Because when you have converted this, only basic operations are required, or mostly two registers are required to performing these operations. So that is the process. So if you are converting this expression, firstly minus c is having higher priority. So priority is according, so minus t1 equals to minus c. Then again, because first priority is basically this first multiply, then t2 equals to b star t1. Then second priority is this particular operation. Okay, t3 equals to again minus c. Although if you are just optimizing this code, then you can take this single particular part, but we will do that in code optimization. That's why we have again repeating this process. t3 equals to minus c, then again t4 equals to b star into t3. Again this whole expression, because this expression is converted into one format, this expression is converted into one format. So firstly, then t2 plus t4 equals to then, and then assignment is there. So here you will see that there are different binary operators are involved, unary operators are involved, some assignment conditions are involved. So all these operations are there. In the later PPTs, I will show you that different kinds of statement will be converted into 3 address code, and there will be a specific process through which the different expressions is converted into the 3 address code. If you are talking about this x plus y into z, you will see that because 2 operators are there, so firstly we have to break into 3 address code. So x plus y into z, because priority is high of y into z, then t1 equals to y into z, and then t2 equals to x plus t1. So that is basically some temporary variables in between you are using, because every time you have to store the intermediate values. For that purpose, you have to generate the temporary variables of compiler generated temporary variables. Like this is second example, that is linearized representation of a syntax tree. Second one is linearized representation of a syntax DAG. There are 2 types of particular representation of this 3 address code. One is in the form of quadruple and second one is the form of triples, which I am going to discuss in next lectures. So linearized syntax tree is basically containing all the particular part. If you are talking about this linearized representation, in which we have just converted into means we have optimized this, because DAG is a process in which we are using, because DAG is used for optimization of codes. So here you will see that optimized code is there, here non-optimized code is there. So in syntax tree, because syntax tree is the part of intermediate code generation, that's why there is no optimization is there, but in that you will see that the length of code will be less. So that is used in code optimization technique, but we are here concerning with this particular intermediate code generation phase. If you are talking about types of 3 address code, so that basically which types of particular statement will be converted into 3 address code. So you have seen that 3 type of assignment statement is there. Okay, one is which is complete 3 address code, because there is binary operator is there. Second assignment is unary operator is there, and third will be is only the assignment statement, or you can say that copy statement. So these 3 kinds of assignment statements, that is basically converted wherever we are getting this statement, assignment statement, where some particular expression values assigned to any single variable, that is basically called assignment statement. So assignment statement is one type of 3 address code where we have some expression, and that expression must contain assignment, and that assignment statement would be converted into 3 address code. What is the purpose of discussing these particular types of 3 address code? Because in next lectures I am going to discuss the how we, whenever we are having any assignment statement expression, how we will execute or how we will convert this statement into 3 address code. There will be some semantic action that is associated with this assignment statement, that is only devoted for assignment statement. So what we are doing, we have to take a CFG, that CFG is specifically devoted or assigned for this calculating this assignment statement or converting the assignment statement in 3 address code. Then another one is unconditional jump, for unconditional jump, then conditional jump, then procedure call, lot of statements is there. So first statement is assignment statement, second one is unconditional jump. That is basically required when you are using some conditional statement. When you are using some conditional statement, at that time unconditional jump is required. Conditional statement then jump is required. Why jump is required? Because if you are taking any conditional statement, there are 2 flows. First flow is when condition is false. Second flow is when condition is true. But sequentially you have that limitation that you have to execute only one statement. So if you are deriving the both 2 statements, at that moment you have to need this unconditional jump. For that we are using go to L. That is simply what we are doing. When one particular statement is completed, like if you are talking about any conditional statement, if or else or any other statement. So if you are taking this statement, if A less than B, then x equals to x plus 1, else x equals to x minus 1. But obvious, if this condition is true, this statement is executed. when this condition is false, this statement is executed, but serially you can only execute the one part of this statement. So for that purpose we are using unconditional jump, because when it is executed, that must be exit. If it is executed, then must be exit. If you are synchronizing both the particular expressions, then what do you have to do? You have to use this unconditional jump for jumping any place. Why it is called unconditional jump? Because sequentially you have to move out from your place to some more distant place. In between there are steps are involved. Okay, then what you have to do? You have to just use some label and you have to go to, like if I am writing go to 3, and here line 1, 2 and 3 is there. So go to 3 is directly jumping out to statement number 3. Statement 2 is omitted. So that is needed, because when we are going to discuss the next statement and we are converting this expressions, different kind of expressions into 3 address code, we will see later. Then conditional jump. If there is a condition, but obvious there is requirement of conditional jump. Okay, so any statement in the form of this, like this I have already written. So then x equals to x1. So definitely this particular part is executed by this label. Sequentially the false part is executed. Then there is a procedure call. Suppose we have any procedure. Okay, in that procedure some functions are defined and that function is executed in some another place. There is some code is given in that function. We have to pass the arguments and then we will getting the results. Whatever iterations are there, for loops are given, anything are given. So for that purpose, if procedure call is there, firstly we have to accommodate the parameters. And what we are doing in here, whatever parameter x is given, that must be into 3 address code form. So if parameter is not in the form of that, like if we are taking function x plus y plus z, you will see that this is the parameter, but this is not in the form of basically this is not in the form of 3 address code. So what we are doing, firstly we have to convert this into 3 address code. Okay, after that this t2 will be the parameter. Okay, so then parameter t1, parameter t2, because both are there, t2 will be used, call p comma n, return y. So that is the kind of, when we are discussing the detailed semantic action of this particular type of statement, we will see these things. Next, index assignment, that is basically array references, that is used for array references. We can also use for 2-dimensional array. So x equals to yi, xi equals to y. Whenever we are going to convert it into 3 address code, both the places, both the statements are different, because in first statement what we are doing, we are found the particular value which is located on ith index of y variable. Okay, y array is ith index, means it is some kind of, this situation is there, 1 2 3 4 whatever I is there. In I, suppose 5th position will be located. So firstly we have to find out the value which is stored in this place. After that what we are doing, we have to take this value and assign in this. In this case that is different, because single variable has stored this value. So firstly we have to find out this base address, then find out the index, the correct position of the particular location where we want to store the value, this, then this value is assigned. So this is called array statements basically. So we are discussing the semantic actions for 1-dimensional array and 2-dimensional array both. Then address and pointer assignment statement. So pointer is definitely define the location of the particular variable. So these are pointer statement, we are using a star for that. Okay, so these pointer statements are also a kind of a statement which is need to convert into 3 address code. So if you are seeing these 6 type of statements is there, which we are going to convert into 3 address code. Okay, so later we will see how we can convert these kind of a statement into 3 address code. That's why we are call it types of 3 address code. Now implementation of 3 address code, that is the work when we are getting 3 address code, after that we are implementing or representing the 3 address code. Okay, so implementation means firstly we have to convert, like we have this expression. What we are doing, firstly we have to convert this expression into 3 address code, then we have to represent these 3 address code into these implementation. So that is called implementation of 3 address code. If you are seeing implementation of 3 address code, it is of 3 types. One is quadruple, the another one is triple, and then last one is indirect triple. As word is indicated that quadruple means 4 things. So if you are talking about quadruples, what quadruple do, whatever 3 address code is given, it will represent it in the form of operator, argument 1, argument 2 and result. Okay, like this particular code is there. What we are doing, firstly we have to convert it into, so quadruple is having 4 parameters. If you are simply say that quadruple is having 4 parameters: operator, argument 1, argument 2 and results. Okay, when we are defining this quadruple, every time you are getting this compiler generated temporary variables, and that variable must be released after completion of the program. So if you will require access to some intermediate results, you will get that. Means in this expression you want to access only this minus c into b, so you will be getting at particular moment of time the value of this. So that is the advantage of quadruples. So if you are converting, if you want to convert this particular expression into this part, because this is directly given but there is in between procedure is there. Firstly what we have to do, you have to convert this expression into 3 address code. So I am going to convert it. T1 equals to minus c, T2 equals to T1 into b, T3 equals to minus c, T4 equals to T3 into b, and A equals to T5 equals to T2 plus T4 and A equals to T6. This is the basic 3 address code. Okay, so this is the basic 3 address code. This one is T1 equals to minus c result T1, T2 equals to T1 into b, T3 equals to this, A equals to T5. Okay, T3 equals to this, T4 equals to this, T5 equals to T2 plus T4 and A equals to T5, sorry, this is T5. So after converting, firstly you have to convert this expression into this 3 address code format. Only then you will find that which one is the operator of first statement, which one is the argument 1 of first statement, which one is the argument 2 of statement, and which one is the result of this particular statement. Okay, after that you will be inputting this into that. So you will see that T1 equals to minus c, here argument 2 is not there because unary operator is there. Okay, so that is the particular representation of quadruple. Okay, so this is the quadruple, but firstly you have to convert this expression into this 3 address code. So every time whenever you are going to implement any 3 address code into quadruples, triples and indirect triples, firstly you have to doing this particular work. It is mandatory for representing this 3 address code. Okay, now next, this is the quadruple. That example is given d plus h by n plus minus c into k. So what we are doing, firstly we have to convert this into 3 address code, then only, because this is the 3 address format, because d plus h, okay, T1 then slash n, T2 then plus minus c is another, T3 then star k, T4, okay, then both will be plussed, that is there, and then equals to 5. What is the pros? Easy to rearrange code for global optimization. So what do you mean by that? We have every time we availability of the particular intermediate values using during this particular 3 address code. Cons, lots of temporary you have to define, means space trade-off is there, space taking more space consuming, because every time you have to define this temporary variables, and that temporary variables will be working for whole the particular operation. Now we are talking about triples. There is only different triples. We are using some pointer statements, and we are using only 3 parameters, that is operator, argument 1 and argument 2. We are storing the values in terms of these pointer of variables. What we are doing, whenever we have used this and we have convert this, we are using this particular expression triples into next, converting it into next triples. These particular variables has been released, means we don't have intermediate values for accessing. In quadruple we may access all the intermediate values, but in triples it is not possible. Okay, so we have already generated minus c equals to 0, this is pointer variable. Okay, then star b, 0 star b, okay, equals to 1, 0 is released, then 2, 0 is released, like that we are using this every time, and this one is released. So that is basically the problem with that, this representation. Here also, firstly we have to convert this expression into 3 address code, then only you can put up these values. Firstly identify the which one is operator, which one is argument 1, which one is argument 2, then only you have to input or insert these particular values in this table. This is a tabular format, but only the drawback is that whenever you require some temporary variables, it is not able to produce you, but it is space, but that it will take less space because there is no temporary variables are defined, so it is advantage. So we are using this triples and quadruples according to the requirement. If temporary variables are required, in between values are required to update or access, then we are using quadruples. Otherwise, if it is not needed, the triples is preferred. If we are, this is the another example for that particular value, this is the example. So we have to convert it into 3 address code, then we have to convert it into triples. So pros cons is there, temporaries are implicit, that are not used. Okay, you are just using these temporaries for defining that expression. Whenever this temporary is used in other places, this will released. One time the particular pointer variable is working. Difficult to rearrange code because we don't have the order, because we don't store the temporary variables, the values, intermediate values into temporary variables. That's why it is very difficult to rearrange. Now we are talking about indirect triples. Basically indirect triples is facilitating quadruples. Okay, in between what we are doing, whatever triples code has been generated, that code is to assign some another pointer variable which will store the particular intermediate code during whole the program. So we can use the particular value for global program. Okay, like quadruples, in quadruples we have store intermediate variables, intermediate values. If these values are required, we have to call this temporary variable and we can access. Same facility will be taken by this indirect triples, but what we are using here, we are using pointers variable, so their structure will be complex. So if we needed something, if we are using some tree structure and we are trying to access the some tree type variables where pointers variables are only used for that, at that moment we are using indirect triples. Okay, most of the places we are using quadruples and triples for the purpose of solving this. So here also we have to convert this expression into 3 address code, then we are putting this table. So what we are doing, this is basically triple 14 15 0 1 2 3 4 14 15 16 17 18, these are the triples. Okay, this triples will be stored into some another pointer variables. So if you need minus c, definitely you will call, because minus c is stored in 0 value. Okay, if you are need b into minus c, then what we call this particular 3, because 3 temporary variable or pointer variable will store that. So in between you are using these temporary variables also, this intermediate values also, by using indirect triples, but it is used very less. Now I will, this is the example 14 15 16 17 18, that is the basic example, and that is assignment of another pointer variables for these statements, so that temporaries are explicit and easier to rearrange the code. So that is the benefit with the indirect triples. If you are compare these, so quadruple, direct access of the location for temporaries, easier for optimization, because every time we have all the values, whatever value we have defined, by using that expression, what is intermediately calculated, that all will be stored in this quadruple. So we can use that. In triples, it is space efficiency. Some more times this is required. Then indirect triples, easier for optimization, space efficiency. So quadruples and indirect triples both provide the same facility, but indirect triples is more complex than quadruples. So in complex cases it is required. After that is not used. So these are the implementation of 3 address code. So initially we have discussed the 3 address code. Then after that, implementation of 3 address code. Now we will discuss the different kind of a statement which must be converted into 3 address code for code optimization, and some particular process is used to convert this into 3 address code. These are new names and labels. Function new temporary variables returns a new name for each call. Function new label returns a new label. So that is for used different temporary variable, because in next particular slides I am going to discuss the process for performing this conversion of simple expression into 3 address code. So now we are talking about assignment statement. So if you are talking about assignment statement, every time whenever you assign any value to any variable, either it is calculated by some expression or it is stored by some single variable, every moment you have to emphasize or focused or publicize that particular operation which is related to assignment. So if you are seeing this semantic action, you will see that this is the basically grammar. S produces ID equals to E. E produces E1 plus E2 is used for solving the expressions. E1 star E2, you can change the operators, plus, star, minus, and divide anything. This is for unary operator. Then this is for when you evaluate any expression, and that expression will be stored into some bracket. Then the final grammar production, E produces ID, where ID is the value of basic operands. So that is the grammar. That grammar is suitable for assignment statement. Okay. So if you are going to discuss this semantic action, so emit is the operation. Emit is the operation which is basically concrete operation. Emit is the function which basically intermediately whatever temporary variable you are performed or inserted, and whatever operations are performed, that must be hidden by using this emit operation. So emit operation, what this does, basically this will generate some finding out the different type of whatever operand is there, whatever types of those operand, that is also find. Then temporary is generated, then assignment is done. Only the basic operation will be shown by this emit, because all the things are hidden in this emit operation. So S produces ID equals to E. If you are taking this expression, emit ID dot name equals to E dot place. Here we are using two particular variable, that is dot name and dot place. So dot place is used for locating the particular location where you are going to store the value or assign the value. Name is the basically used for the operator, the particular value which is stored to this location. So if you are taking emit ID dot name equals to E dot place, here E is the particular expression or particular variable where some calculated value in terms of ID is stored, and that value is assigned to capital S. So here single assignment is there, but the value of ID is came from a larger expression. Means we have a larger expression like A plus B into C by D plus E. That is basically larger expression. So this larger expression is converted into one particular value, and that value is stored into the capital E, and after that, that capital E is finally assigned to capital S. So that will show that you have already solved this expression by using this assignment statement, and the final value is stored into S. So whenever we are getting the final value, at that moment capital S produces ID equals to E. This particular production is used. In between, E produces E1 plus E2, that is intermediate operations, because we are taking some binary operators, and these binary operators using two operands, and that operands will be using this operator and finding out the results, and after this result is stored into some single variable, and that again is used for some different operations. That is basically E produces E1 plus E2. So E dot place equals to new temp, because E is the particular location where the calculated value which is converted into single value is stored. So E dot place equals to new temp, because it is basically E produces, if you are writing E1 plus E2, so that is T1 equals to E1 plus E2 and E equals to T1. So that is kind of assignment. Okay, so firstly E1 plus E2 is calculated and stored into some temporary variable, and the value of that temporary variable is assigned to capital E. So E dot place equals to new temp, emit E dot place. What is major operation performed? E dot place equals to E1 dot place plus E2 dot place. Firstly E2 dot place value is taken, then E1 dot place value is taken, then plus operator is performed, that is converted into single value. That single value is stored into new temporary variable, and then new temporary variable is stored to, okay, कर लो, complete कर दो, ठीक है. Okay, so this is E dot place equals to E1 dot place plus E2 dot place. Similarly, you are talking about E1 is star E2. So that is also same operation. Similarly, E produces minus E1 is also same. E produces bracket of E1, only the particular variable is changed because E1 dot place is converted into E. And E produces ID because the basic operand will be taken like A, B, C, D, all. So this is for assignment statement. So you will see that whatever expression we have to take every time where assignment is there, either ID is assigned to a particular variable, either calculated expression converted into single value and assigned to some single variable, or the complete final value is assigned to a single variable, that all assignment will be shown into that. So today I am going to, I have discussed till now. The next particular content I will discuss in next lectures. Thank you very much.